Good day, everyone. I simply want to answer a very important question this moment. Why is the electronic configuration of potassium 2881? Despite the fact that the K shell takes 2, L takes 8, and then M takes 18. And so the M shell is not filled. Why go filling the N shell with one electron when simply we can have it as 2, 8, 9 because the M shell is not filled yet. Briefly, I'll be explaining this question. I came across this question in my secondary school, and simply my teacher told me to just assume it is 288. But that never made sense to me. This moment, I'll be answering this important question this morning. This is Gifted Brain, aka Saizu, first in Africa, sixth in the world. Actually, the K shell takes 2 electrons. The L shell takes 8. The M shell takes 18, while the N shell actually takes 32 electrons. And the formula is just 2n squared. 2n squared. You see, the K is represented with 1. The N value is 1. The N value is 2. The N value is 3. While the N value is 4. So if you use that into this relationship, you will get the same value of 2, 8, 18, 32. Okay. But I want to explain this morning what I assume you must have seen before now. That the K shell has also the 1x. It has 1x orbital. The L has 2x and 2p orbitals. The M has 3x, 3p, and 3d orbital, while the N has 4x, 4p, 4d, and 4f. I want you to notice something, how numbers repeat here. 1 here, you see 1 in the K, 1. You see 2, 2s and 2p. Well, I just want to let you know that the 1 here means the N value of K, which is the shell value of K. Or you say the energy level of K is 1. So L, 2, that's why you are saying 2x and 2p. M, 3s, 3p, 3d. Another thing I want you to know again is that the S takes 2 electrons. The S sublevel actually, or you say sub shell, takes 2 electrons. So the P subshell takes 6 electrons. The D subshell takes 10 electrons, while the F takes 14 electrons. And so you can understand why we said that KLMN takes 2, 8, 18, 32. And that's because since X takes 2, S takes 2. So that makes up for the 2 electrons in K. The L takes 2 and P takes 6. 2 plus 6 give me 8. That is the reason why L can take 8 electrons. The M contains 3x, 3p, and 3d. So you see why we have 2 electrons in the X, 6 in the P, and then 10 in the D. So 2 plus 6 plus 10 gives us 18. The same thing for N. N has 4x, 4p, 4d, and 4f. So we have 2 electrons in X, 6 in P, 10 in D, and 14 in F. If you sum this up again, you get 32. But I want you to remember clearly that the electronic configuration of any element is not arranged in this format. That Alva principle tells us the order of the increasing energy level. That we move from 1x like this to 2x. As we move after 2x, we move to 2p and then 3x. After which we move from after 3x, we move to 3p and then 4x before 3d. Take note, before going to 3d. So the order is given below as 1x, 2x, 2p, 3x, 3x, 3p, 4x before 3d. This is what Alva help us to realize. Note something here now, that if you are feeling the 1x, have it in mind that you are feeling the K shell. If you are feeling the 2x, have it in mind that you are feeling the L shell. When feeling the 2p, you are still feeling the L shell. When feeling the 3x, you have now moved to the M shell. When feeling the 3p, you are still in the M shell. But when feeling the 4x, you are feeling the N shell, after which you are coming back to feel the 3d, which is the M shell. You see, we move from M to N and then back to M. So if I write out the electronic configuration of potassium now, using the sub-level, you will have 1x2, 2x2, 2p6, 3x2, 3p6, 4x1. Take a pause a little while and look at this. Note something. We have filled the K with 2 electrons now. These 2 account for the L shell. We filled it with 8 electrons now. And now we have filled these 2, 3s and 3p, which is account for the M shell, with 8 electrons as well. And now we are filling the N shell now with 1 electrons. That's why we have what we have. What happens if I am going beyond potassium? Let's go to calcium, for instance. If I'm going for calcium, I will have the same thing happening. 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. A similar thing here, you will realize that what we have is 2, 8, 8, 2. So that's what we have. 2, 8, 8, 2. This is my M, this is my L, this is my K, and this is my N. So had it been we move to the next element after calcium, because calcium is the 20th element, I'll be talking about scandium. At that point in time, I will need to write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d1. Note something here, that this is the K, these 2 make up the L, these 2 make up the M, and this make up the N, and back to another M. So you see that if I'm to write, I will have 2, 8, these 2, the M and the M here again. So this M, not N. This M, not N, because this 3D. And that this will be 292 for scandium. 292, because I have filled the 3D1. So we should add to the M, because I have 2M here, 1M here, and 1M here. So that is what is happening. I hope I've been able to explain to you why we have 2881. Thank you very much.